We are aboard the University of Miami research vessel Walton Smith on a cruise to Ground Zero in the Gulf of Mexico, the site of the Deepwater Horizon oil and gas release.
It is a thermogenic source, but it's coming from a broken wellhead.
University of Georgia marine sciences professor Dr. Samantha Joye searches for a huge underwater oil and gas plume thousands of feet below the surface, first discovered on a research cruise into the Gulf shortly after the disaster began. Now on station about a mile and a half from the site of the disaster, the researchers begin their work. Even at this distance, the air is acrid with the unmistakable smell of oil. In some areas, the odor is so strong the researchers don masks to help filter the smell.
It smells bad. It smells like it's a combination of gasoline, diesel, and creosote. That's about as best I can describe it.
The research team's first task is to comb the depths to redetermine the location of the oil and gas plume discovered by the Pelican cruise 3 weeks before. Initially, they try using chirp sonar to see if they can locate the oil and gas plume, but no luck. The oil and gas plume is either transparent to sonar or it has moved.
I'm probably going to go actually north to see if this feature is, I'd like to go another mile north of this line and see if we can find the plume up there.
So they decide to investigate the profile of the water column with sensitive detectors, which tell them layer by layer exactly what the water below the ship contains. The device they use is called a CTD rosette. It's the team's main research device. It's a 1,000-pound device lowered from the ship to the very bottom of the ocean 1 mile below. On the way back up, special containers extract samples from the ocean, which are then analyzed by chemical sensors, which feed the information back up to the powerful computers in the floating science lab thousands of feet above.
And as it goes through the water column, there's a live data feed up through a conducting cable, so we can sit at a computer in the ship and see effectively the chemical signature of the water as the system goes down through it.
Although the teams made 3 casts with the rosette, they have received no hard data indicating the whereabouts of the Pelican cruise oil and gas plume. Dr. Joye instructs the crew to move the ship about a mile due north in search of the oil and gas plume. The rosette is dropped again, and the team members cross their fingers.
I'm just worried we're going to miss the...
Dr. Joye's team has found a new oil and gas plume between 800 and 1,300 meters in depth, and it appears to have 3 distinct layers. It's big.
We found probably the most intense plume that we've seen out here so far during this trip. It's a little to the south of where the Pelican cruise found their plume 2 weeks ago, and it's to the about 3 or 4 miles south of the track we were running the other day when we saw what I thought was a pretty intense plume. This one is at least 3 times more intense than that one.
The feature that we found was around, I'd say, 20 nautical miles or so long and up to 3 nautical miles wide, and the main plume, the heart of the plume, is from 1,100 to 1,300 meters water depth, so 600 feet thick. There were some places where the actual depth signature was from 800 to 13 meters, so it spreads out as it starts off thin and then spreads out as it goes out away from the source.
With this new oil and gas plume located, team members begin work analyzing the water samples taken directly from inside the plume. When we return, media interest in Dr. Joye's cruise is intense, and the team continues sampling the ocean water, including surface samples.